looking at some special cases for expanding. The first one I'm going to look at is difference of two squares. So I'm going to expand it the same way and show you what the pattern is. I draw in my eyebrows, draw in my nose, and draw in my mouth. When I do my eyebrows, I get m times m. Then I've got plus 3 times negative 3. Then for my nose, I've got 3 times m. And then for my mouth, I've got m times negative 3. So when I go through and simplify that, I get m squared. My 3 times negative 3 gives me minus 9, plus 3m, and then I've got take 3m when I do the negative 3 times m. This is where it becomes a special case, because we've got plus 3m, take 3m, they cancel out, and we're left with m squared, take 9. So if you see the pattern there where you have a plus and a minus and the same number there, or the same term, you can, and the first term is the same there, you can identify it as a difference of two squares and use the pattern. The second one here we've got is a perfect square. So it's not a difference of two squares because we don't have the two different operations there. We've got one bracket with a squared, which we can write as the same bracket multiplied by itself. When we expand that, putting in our eyebrows, our nose, our mouth, we'll do our first eyebrow, a times a, second eyebrow, 4 times 4, mouth, a times 4, and nose, 4 times a. So we get a times a is a squared, 4 times 4 is 16, a times 4 is 4a, and 4 times a is 4a. And this is where our pattern occurs because we get the same term there. So when we simplify, we end up with a squared. We have 4a plus 4a is 8a, and then we have the 16 on the bottom at the end. So when we look at that, our pattern is that our first term is squared, our second term is squared because that's 4 squared is 16, and then this middle bit is 2 times a times 4, so those two bits from our bracket. So that's our perfect square pattern, which is a plus b all squared is going to give you a squared plus 2ab plus b squared.